What's up, guys? If you don't know anything about logarithms or exponents, or you just forgot it, this is the video for you. So let's get right into it. So this is my little challenge problem for you guys. It's given the following equation. Show that this entire mess right here, show that a has to be equal to plus or minus 1, okay? So if you don't know how to do this, by the end of the video, you should be able to solve it, okay? So let's get to the first point here. So first question is, what is an exponent? And essentially, an exponent is just a helpful way to tally up the number of times you multiply something by itself. So let me show you what I mean. If we have 4 to the 4th power, that's just the same thing as saying 4 times 4 times 4 times 4, right? And this takes up a lot of room, so mathematically, it's a lot easier to write it as 4 to the 4th power. So basically, like I said, it's an operation that tells us how many times we should multiply a number by itself. Okay, guys, so there's some rules with exponents, okay? And you might be familiar with these from grade school, but we have that x to the a power times x to the b power is equal to x to the a plus b power. And then we have this whole mess right here. And then we have this rule right here, okay? So let's go ahead and just talk about it, and let me explain why that is the case. So if I have x to the a times x to the b, this always has to be the same thing as x to the a plus b. So let's think about it, guys. If I have 4 to the 3rd power, and then I multiply it by 4 to the 5th power, this is the same thing as saying 4 to the 3 plus 5 power, or 4 to the 8th power. And let's think about why, okay? So if I have 4 times 4 times 4, right? 3 times. And then I multiply it by 4 times 4 times 4 times 4 times 4 for 5, right? This is just the same thing as saying 4 times 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 4. You get the point, right? We have 1, 2, 3, 4, 5, 6, 7, 8 terms here, 8 fours. So it has to be the case that you're actually just adding those exponent values, okay? So when you have numbers, right, you can get clean values like 8, right? But if you're dealing with variables, then you just leave it in this form right here, okay? Just a plus b. Okay, so hopefully that makes sense for that one. So let's go ahead and move on to the second one now. So let me go ahead and clear some room. So if you'll notice, the second one here is basically just a special case of the first one, okay? So notice that we have the same form here, right? Multiplying two exponents that have the same base. But in this case, x to the negative b, that's just the same thing as 1 over x to the b power. So what we're going to do is we're actually going to subtract these two because we're really just, this is really just the same thing as x to the a, x to the a, oops, x to the a plus negative b, which is equal to x to the a minus b. Okay, so hopefully you see that. And let me just show you real quick an example. So if we had something like 4 squared multiplied by 4 to the negative 3, well, this is really just the same thing as saying 4 times 4, and then all that is going to be multiplied by 1 over 4 times 4 times 4. So when we simplify this out, we're going to get 4 times 4 divided by 4 times 4 times 4. And then these 4's are going to cancel out, and I'm left with 1 over 4, which is equal to 4 to the negative 1, and we will see that 4 to the 2 plus negative 3 is equal to 4 to the negative 1. Okay, so hopefully that makes sense, and that does in fact check out. So now if we want to go on to the third rule here, it's even more simple than that, okay? All this is saying is I have some x to the a's, and I want to figure out how many times I'm multiplying x to the a by itself, okay? So for example here, if I have 4 to the 2nd, and I want to take that to the 4th power, well, that's just the same thing as saying 4 squared times 4 squared times 4 squared times 4 squared, okay? And if you notice anything about this, this is equal to 4 to the 8th. So if I rewrite this entire thing, I have 4 times 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 4. And whenever we add up all these 4's here, I get 1, 2, 3, 4, 5, 6, 7, 8. So I, in fact, have 4 to the 8th power, or 8 4's, okay? So hopefully that makes sense, guys. Let's go and move to the next one. So this is probably the biggest issue that people run into is not understanding what a logarithm is. So let's get right into it. A logarithm is an operation that tells you how many times you must multiply a number by itself to get a certain number. So let me explain. It has this form, log base b, with x as the, what we call this, the argument. E is equal to p, okay, or the power. So basically all this is saying is b to what power gives me x, okay? So it's the inverse of an exponent. So let me go ahead and give you a little example here, okay? So if I have log base 10 of 100, and I want to figure out what that equals, I have to ask myself how many times, or I should say 10 to what power, we'll call it a, right? To what power equals 100, okay? So this is basically all I'm asking myself. And I know that 10 squared equals 100. So 10 to the 2 equals 100. And that means that the logarithm of 100, if the logarithm has the base 10, it's going to be equal to 2, okay? So really, I'm just asking myself, 10 to what power gives me 100, okay? So let's keep going, and it should make more sense as we get into it. So how are logarithms and exponents related? Well, they're related through this expression right here. And this is kind of what I was trying to say. The log base b of x equals p. That's the same thing, or that's equivalent to saying the base b to the power p equals x. Okay, so again, with this logarithm, I'm asking myself, b to what power gives me x, right? And that means that b to the p will give me x. Okay. All right, so hopefully that makes sense, guys. I'm trying to think if there's any other way I could explain it, but I think as we keep going, it should make more sense. Okay, so these are some logarithm rules that are extremely important in math in general, but especially for the SAT and GRE and ACT, because they will test you over this. So we have this first rule here, whoops, first rule, second rule, and the third rule, okay? So you can go ahead and read it for yourself, but let's go ahead and see if we can understand why this is the case. So starting with this one right here, why is it that the logarithm of x times y is the same thing as logarithm of x plus the logarithm of y? And let's go ahead and see if we can do a little derivation here. Okay, so stay with me for this. If it looks complicated, don't worry, I'm going to explain it more, okay? Okay, so let's go ahead and assume that x equals the base b to the power p and y equals b to the q power, right? So we're just going to make this assumption. You don't really need to understand the symbols right now, but we're just saying, let's just assume that x equals this thing and y equals this thing, okay? So if I take the logarithm of both sides, I'm going to get this, right? And that, okay? So hopefully you should see that. That should start making sense. Now, whenever I simplify out this equation, so log base b of b to the p, right? Whenever I simplify this out, I know that if I have a base here and I take the logarithm in that base, it's just going to be equal to 1, right? So what I'm going to be left with is p, okay? Or even, it would be p multiplied by the logarithm of b to the b, and then we just get p times 1, so I'm left with p, okay? So hopefully that makes sense. And another way that you can think about this here is you can ask yourself, okay, what power of b gives me b to the p, right? And of course, it's just p, right? So what power of b gives me b to the p? It's just going to be p so that I get b to the p, okay? So hopefully that makes sense. And then we're just going to do the same thing for this one right here, and then we're going to get q, okay? So hopefully you see that. So now what I want to do is I want to say, okay, well, what's x times y, right? So if I take these values for x and these values for y, and I plug them in here, I get this, right? B to the p power times b to the q power. Now, whenever I simplify this using our exponent rules, I get b to the p plus q. So we just talked about that, right? So that is what it's going to equal. So now, guys, if I take the log base b of both sides, it's going to look like this, right? So now I have log base b times x times y, and then this entire thing right here, okay? So like we talked about previously, if I have log base b and then b to the p plus q, well, I want to ask myself, b to what power gives me b to the p plus q? And that's just going to be to the p plus q power, right? So now we have this. And now, guys, what I want to do is plug in our values. Sorry, that should say plug in our values for p and q. So we know that p and q equal these values, right? So now I just plug these values back in for p and q, right? And now look, guys, we get our rule here. So voila, right? Basically, we just showed that if we have these values, then this rule has to be true, okay? So we just derived it. And hopefully that makes sense, okay? So anytime you see something that looks like this, that is equivalent to this, okay? All right, so now let's go ahead and just double check and make sure that this does in fact work, okay? So what I want to do here is just do an example, okay? So let's take log base 10 times, with 10 times 10. So it's going to be, is log of 10 times 10 equal to the logarithm of 10 with 10, or the logarithm of 10 with 10? If we add them together, are those equal? So let's see. Well, we know that the logarithm of 10 times 10, that's just the logarithm of 10 with the, what's the word here? Sorry, I'm going to lose my words. Logarithm base 10 of 100, right? That's the same thing. So we need to ask ourselves 10 to what power equals 100? And we know that that's 2. So therefore, the logarithm of 10 times 10 equals 2. Now, what about log 10 base 10? Well, guys, like we talked about, right? If I have this right here, I'm asking myself 10 to what power equals 10, right? And we know that 10 to the first power equals 10, so this is going to equal 1. So whenever I plug in these values here, so let's see, I have log 10 times 10, this is base 10, right? And I'm wondering, does that equal log of 10? Right, plus this thing right here. Sorry, it's getting kind of messy. Well, I know that this is equal to, I know that the left side is equal to 2. And then I know that this right here is equal to 1, so then I just have 1 plus 1, so I have 2 equals 2. All right, guys, so that checks out, so we're good. So now, guys, what we're going to do is derive the second rule. And again, the second rule is just a special case of the first rule when one or more of the exponents is negative, okay? So remember that rule was going to be log of x divided by y equals log, let's see here, x minus the log of y, right? Now, and again, it's base b, right? So really, what the left side is saying is this is just saying log to the base b x multiplied by y to the negative 1 power, right? So we would expect that we would get something that looks like this, but let's go ahead and prove it. So guys, basically, we're just going to do the exact same thing that we did before, but it's going to be slightly different, okay? So we're going to make these assumptions again, right? And then we're going to do the same thing here. And then we're going to simplify both equations. But now, instead of doing x times y, I'm going to do x divided by y, okay? So what I'm going to end up with is this whole thing, right? So now I'm going to substitute in these values, and then I'm going to simplify them, and I'm going to get b to the p minus q instead of b to the p plus q, all right? So now, guys, whenever I take the logarithm of both sides, it's going to simplify down to p minus q. And now if I plug in my values for p and q, if I plug them in right there, then I'm going to get this value right here, okay? So hopefully that makes sense as to why that's the case. All right, guys, so now what I'm going to do is I'm going to talk about the, well, we'll just double check and make sure that this works, okay? So we're going to do the same thing, all right? Is the logarithm of 10 divided by 10 equal to logarithm of 10 of 10 minus logarithm of 10 of 10? So we know that 10 divided by 10 is 1. So now what I need to ask myself is what does this equal, right? So logarithm of 10 of 1, what does that equal? So we did ask ourselves 10 to what power equals 1? And we know that 10 to the 0 equals 1. So therefore, this is equal to 0, okay? So this is equal to 0. So we know it's equal to 0. Now, guys, if we go over here, let's go ahead and write it out. So I have 0 equals log of base 10 of 10 minus log of 10 base 10. And I have to ask myself 10 to what power equals 10, and it's just 10 to the 1. So I have 0 equals 1 minus 1, and that is going to equal 0. So that checks out. All right, guys, so now let's just talk about the third rule. And I was going to derive it mathematically, but let's just kind of reason this one out, okay? So the third rule states that log base b of x to the y is equivalent to y times log base b to the x, okay? So let's go ahead and see if that is true. Okay, so if I have the log of 10 to, or the logarithm of 10 to the third with base 10, I'm going to get this whole thing right here. Now, 10 times 10 times 10 is 1,000, and we have to ask ourselves 10 to what power equals 1,000. And that power is going to be 3, right? 10 times 10 times 10 is 1,000, and that's 3 tens. So it's going to equal 3. So now, guys, if we bring this 3 out here, right, and I get 3 times log of 10 to the 10, or the logarithm of 10 to the base 10, this is going to equal 3 times 1, which is going to equal 3. So we get the exact same result. So this checks out, okay? This is a very important rule. Make sure that you understand this one. All right. So now, guys, we have finally made it to the big, nasty challenge problem, all right? So we're going to have to take in everything that you've learned from the last few videos to solve this one, all right? So let's get right into it. So the first thing that I want to do here is I want to work on this side, okay? And don't be scared because, you know, there's x, there's a b. we want to solve for a. All right, so let's go ahead and try doing that. So first thing I'm going to do is let's go ahead and write it out. So if I to the a times the natural log of x to the e to the negative ai plus e to the negative ai. And what I want to do is I want to break this up into two things. So it's really going to be e to the b multiplied by e to the negative ai. Okay, so now we have all this. And this is equal to I to the a times the natural log of x plus e to the b plus 1. Okay, guys, so now what I want to do is I want to factor out an e to the negative ai. Okay, so it's going to be I to the a times natural log of e to the negative ai x plus e to the b. Okay, so now we have these two values here, and then again it's going to equal I to the a times the natural log of x plus e to the b plus 1. So now, guys, I want to break this up into two logarithms, okay, kind of like what we did in that last rule. So it's going to be I to the a multiplied by the natural log of e to the negative ai plus the natural log of e to the, e to the x plus e to the b power. And this is going to equal all this stuff right here, okay? So now what I want to do is I want to go ahead and simplify this down. So let me just get a good look at it real quick. Okay. So I'm going to have I to the a and the natural log of e to the negative ia plus I to the a natural log x plus e to the b, and this is going to be equal to the natural log, I to the a of the natural log x plus e to the b plus 1. So now, guys, what we can do is we can actually just go ahead and subtract off this entire thing right here. So these are going to cancel, and if I subtract off this whole thing right here, these are also going to cancel. So now I'm left with I to the a times natural log of e to the negative ia equals 1. So now, guys, we're going to have to use that other rule where if I have an exponent, right, this exponent right here, I can bring it out to the front. So I'm going to do negative I to the hang on, let me write that. So it's going to be negative I times a multiplied by I to the a. That has to equal 1. All right, guys, so now what we want to do is we want to ask ourselves what value of a could give us these two things right here. And we know that, well, actually, hang on, let's simplify it one more time. So now I'm going to simplify it, and I'm going to combine these two i's here. So I'm going to get negative a times I to the a plus 1. Okay. So we know that I equals the square root of negative 1. So I squared is going to be negative 1, right? So if we look here, we need to get a positive 1 here. So I need this to equal negative 1 and then to have negative a equal 1, right? So if we look here, we can see that a can either be positive or negative. And that is our answer, all right? And let's go ahead and plug it in and just show that that works, okay? So if a equals 1, we're going to have negative 1 times I squared, which is going to be negative 1 times negative 1, which is going to equal 1. Okay, now if I do if a equals negative 1, well, then I'm going to have, let's see here, 1 times I to the to the 0. And that is going to equal 1 times 1, which is going to equal 1. All right, guys, so that is our answer, and hopefully that made sense. I know that was kind of a longer video, but once you make it past logarithms and exponents, it's all going to be downhill. It's going to be really easy to get the rest of the material. So, guys, if you have any questions, always feel free to comment below. And yeah, if you wouldn't mind liking and subscribing to this video, it would be greatly appreciated. I kind of took a lot of time distilling this video down to just the the basics so you could understand it quickly. So yeah, feel free to like and subscribe, and I'll see you in the next video.